Okay, this is the last one. I'm kind of going in weird order because I think this is the one you know how to do the most. Okay, so we have a chi-squared table here. Couple things to remember. Kind of briefly skim it. But they're figuring out whether people think the voting age should be reduced to 16. So a couple things you want to remember. Do not enter the totals into your matrix. So I'm going to enter my values into my matrix. And this is a 2 by 3. Just make it match up. 12, 20, 48. 18, 15, 17. So I'm exiting out of there. I have it stored in matrix A. And I want to run a chi-squared test. So stat test chi-squared. I'm going to put the expected values in B. I'm going to write down everything that I did. So I'm going to calculate the chi-squared is 10.3. Degrees of freedom equals 2. P equals 0.00573. So those are my possible data values. So let's see what we have. It says the chi-squared critical value. That's the value from the table is 9.21. Null hypothesis. Write the word independent. Whether or not they are in favor of this is independent of their age. Alternative would be not independent. Don't write dependent. It's not independent. Those are just words. Okay. Write down the number of degrees of freedom. Already got it. It's 1 point, so you can use your calculator. And then it says show the expected frequency of those between 26 and 40 who oppose a reduction is 21.5. Okay. So oppose and 26 and 40 would be this one right here. So I'm going to look up above and below, to the right, I'm sorry, and below. So I'm going to show that. To get that 21.5, I took the column total times the row total and divided by the overall total. And you show that, and you should get the same value. Find the chi-squared statistic. We did 10.3. The associated p-value for the test, we did 0.00573. Determine giving a reason whether you should accept the null hypothesis. So if the chi-squared calculated is greater than the chi-squared critical, or the table we called it, then we reject the null. And p is the opposite of that. If p is less than the significance level, which is 1%, then we reject. So let's see if they back each other up. Chi-squared calculated is 10.3. Chi-squared critical 9.21, so it's greater than, so that's reject the null. We always assume that they're not related, but we check to see if they are. And the critical is less than, so it supports our finding. So our final conclusion, determine giving a reason. So you could do either one. They ask you for chi-squared and p, let's do. So you would say whether people are in favor of the change is not independent of their age. And then I would include this, and you could even say further, and the p equals 0.00573, and that is less than 0.01. So further supports it. So there's your reason behind that. Sometimes it's one or the other, sometimes it's both.